Hello friends, welcome back. In this session, we'll clearly understand something called as ensemble learning. This is a very important concept and this carries a lot of respect in the market and people use it quite frequently. I'm going to take up very simple examples and I'll explain you what it is and I'm sure you will like it. But before we go technically into it, we need to understand one thing. The wisdom of the crowd is the basic saying that we are going to follow here. Together we can achieve multiple things. Alone we could do a very little things only. This is what Helen Keller said, and that's absolutely suiting here for the ensemble learning. Ensemble model brings the concept of combining multiple models together to get the best accuracy and to improve the predictability of the models. So we will have something called as the bagging, the boosting, all these things, but all these come under the ensemble modeling. So we will understand first the fundamental of the ensemble modeling, and then we will go deeper into what is bagging, what is boosting, all those things. I'll teach that in successive sessions. Well, before we go into it, let's understand or assume that we are developing a machine learning model that is going to predict the stock orders, inventory of the stock orders, right? We have historical data available with us and the previous year's data are all with us. We can use the techniques like the linear regression, the support vector machine, the decision tree, neural networks, all these things can be used and we can build models. But one thing that we have seen is when we use linear regression, the accuracy is say 75%. SVM when we use say accuracy is 90%. Decision tree when we use the accuracy is 85% and neural network it is 90 plus. Nowhere we got the 95 plus percent accuracy which we were really expecting. So what do we do? Very simple. All these are providing some results which are not up to the mark. Being weak doesn't mean they are useless, right? You can combine all of them into an ensemble and you will get the best results. So you are going to combine all these models which you have developed and you are going to ensemble it to get the best of the results, and that's what is ensemble modeling is all about. They combine multiple algorithms and most commonly they are used for regression and classification problems, and this also help you in reducing the bias and variance to improve the accuracy. The concept of base learners is used here. I'm going to show you that as well. They incorporate the predictions from all the base learners or the models to build a more accurate model. It's like taking it from all of them and then building something very accurate. So you are brainstorming an idea. For an instance, you are brainstorming a particular idea and multiple suggestions will come in from multiple people who are sitting in that room. That will ideally improve the efficacy of the idea, right? So that's what is ensembling here. There are multiple models that are available and each of them will have some value, and combine all of them to eradicate the negativity and bring the best out of it. That's what is ensembling. Now, if you see here, there's a very simple representation we have given here. You can understand that the data set is used here. We are considering the data set and we are going to train with various models. So once the training of the model is done, we use a concept called as combiner. We can see that combiner is presented there. A single model would be considered as a single base learner. I used this term base learner some time back. Now you can understand a single model is considered as a single base learner, which may not be really useful for you, which may not give you high best results. But when you combine, when you use the combiner, which can combine model 1, model 2, model 3, model 4, model n, you get the optimal performance. That's what is ensemble learning for you. The ensemble learning is classified into homogeneous ensemble learning models and heterogeneous ensemble learning models. When you go with homogeneous, it has got bagging and boosting. When you go with heterogeneous, it has got stacking. We will talk about all these in detail and it's going to be very helpful for you to understand things. I hope till now it's very clear. The next session I'm going to take you through the bagging and I'll also explain you the types once again so that you can understand things better. If you have any questions, please type it in the chat section. I'll be able to take it up. If you like the channel, kindly subscribe. Thank you very much.